Okay, so is the mic okay? So can everyone hear me? Okay. So minasan konnichiwa. So that's pretty much the only Japanese I can speak now. So it's really my pleasure to be here to present our work with AllSeen. So I'm European, so I'm working with ThroughTek. So today I'm going to talk about how to integrate AllSeen with your platform. So our platform is Kalay Platform. So I'm going to talk about designing for this interoperability, which is really the very strong feature for AllSeen. So I think from the morning session with Philip and also the Gateway agent, I think people here should already know about AllSeen if you are not already an expert. Okay, so then to talk about integration, then I think I probably need to talk about our work here to introduce our Kalay platform. Otherwise, people may not understand why we are doing integration here. So, and I'll try not to talk about too much about our Kalay platform, which might sound like kind of advertisement here. But actually, I really want to talk about how easy to integrate AllSeen with your product or with your solution. So, so here is my, okay, yeah, sorry, I don't have the pen here, so, okay. Okay, see it. Okay, so here's my agenda here. So first, I'm going to do some introduction about ThroughTek and our Kalay platform. And then I'm going to talk about a real case. Actually, we built up a prototype with AllSeen and AllJoyn framework with the Kalay platform. So I'm going to do a simple. I'm trying to do a live demo here, but actually I think it's probably not easy to do a live demo. But actually we do have a clip from earlier MWC demo. We work with AllSeen to have a live demo in MWC. So actually we also have a clip there. And actually this clip is also taken from AllJoyn channel in YouTube. So I'm going to share that clip which will show how this prototype doing with AllSeen and our Kalay platform here. And then next I'm going to talk about how this works with AllJoyn integrate with Kalay platform. How easy you can do this without too much modification to the AllJoyn source code. You don't really need to get into the very deep understanding of the entire AllJoyn. You can just use what AllSeen offer, the basic service, to really get what you need here. And then I'm going to talk about what kind of issue and difficulty we have when we're doing this kind of integration. And finally, I'm going to talk about what other future possibilities with AllSeen and with this kind of integration. So first, I'm going to talk a little about our company and our platform. Then it will be easier for people to understand why we are doing this integration here. So, so what is ThroughTek? So actually, we are committed to the IoT, Internet of Things, and M2M service. We set up our Kalay platform with three main components with the cloud service on the top, and for the connection with the device, and also the Kalay application. So we provide a total solution for this kind of connectivity platform for your device to connect to the cloud service and then to the client-side application. So we can try to support a very streamlined enterprise entry for the customer to go into the IoT and M2M market. And then we build up a very robust cloud functionality with the very modular and the scalable architecture. So actually, we've been doing this kind of cloud connectivity service for several years. So next, we are going to show some statistics to explain what the performance of our platform and what we can do here with this kind of service. Okay, so. Okay, then so next, I think we probably also need to talk about what we can do with the AllSeen, since we're already a member with AllSeen for, I think, at least a couple of years. And I think we just try to get more involved starting last year, try to see how we can work with AllSeen to develop some kind of strategic services to optimize the product experience. A lot of our customer partners, they want to use AllSeen, but they don't have the exact idea what AllSeen can do. So here we can really help people to understand what you can do with the AllSeen. And then we also try to work with different companies to have different product lines and also different industries, from the security surveillance industry to the smart home, and also to different type of enterprise solution as well. And to the end, we try to create more opportunity for this huge IoT market. And we also try to create a more different kind of product that can really be interoperable in the future, so that it's not just the product that's using our solution, but with this AllJoyn framework built in, you can really work with different products that are made by different manufacturers. So next, some facts about ThroughTek here. So we started in July 2008, so actually it's already been 7 years now. So we have employed over 150 employees. So about 60 to 70% people are really R&D people here. And our headquarters is based in Taipei, Taiwan. And we have several branches. So 2 branches, Shenzhen and Shanghai in mainland China, and the office in Hong Kong, and then another R&D office in Yilan, Taiwan. So for our platform here, we have so far, so this number is coming from just May. So far we already have over 6 million devices connecting on our platform. So about 50 to 60% of all these devices are surveillance system or IP camera, and some of them are storage device, NAS, and there's also NVR, DVR, and there's about like 10 to 20% are smart home devices. But the smart home devices are getting more now. And all these devices contribute to over 90 million connections per month. So the connection means from client side to the device, which means it can be an Android smartphone or iOS home app that connect to an IP camera or to a NAS storage, or it can even be a device-to-device connections that between like an IP camera and a storage box as well. So then you're probably wondering why we call our platform Kalay. So actually this is kind of from an Aboriginal tribe in Taiwan, because we're based in Taiwan. So this handshake is really from this kind of Aboriginal language, which means handshaking. So we use this term to represent that we want to connect all the IoT devices, not just IoT, all the devices in the world, so that every device is handshaking with another device. So that's why we use this handshake, use this Kalay for the name of our product and our platform. So these are more like this about the end product for our applications. So most of them are like, so they might be a surveillance system, and this is probably NAS storage, and also some smart home devices and set-top box. And there are also some interesting applications, like this one is a Roomba, iRobot vacuum cleaner. So they just build in a video inside the cleaner here. So you can use your app to control the robot and then to see where it's doing the vacuum cleaning right now. So it's kind of interesting. So which means our solution can be applied to different kind of devices, not just surveillance system. Although we started with surveillance system in the very beginning.
Excuse me?
Yes.
Does your company develop these all products?
We are a pure software solution company, so we don't manufacture product. We don't do hardware.
So you just provide?
Yeah, we provide a solution. So our platforms, I think I probably talk about our platform, but basically we can integrate with the firmware and then provide the application. So we provide a complete solution for the software. So a lot of our customers are really hardware manufacturers. So,
how about the cloud?
Yeah, we also provide cloud services as well.
So you are running data center?
Yeah, not data center. We use AWS software, all these kind of cloud services. So we set up our service on those cloud services like AWS, Amazon, EC2, or IBM software. So we don't really build data center, which will be a very huge investment. Okay. So feel free to interrupt me anytime if you have some question. I think that can make this presentation more interactive. Otherwise, I'll just continue to speak, and I'm not sure where I end up with. Okay. Oh, that. Okay. I think I click the wrong button here. Okay, so for the smart home industry, especially here, so I think I can probably talk about some partners or some areas we are working with. So for example, for the surveillance or security system here, so we are working with Bosch or ASP for the alarm system. And then for the, then there's also smart plug. We also work with some smart plug manufacturer. So smart plug is also one very important component, especially for smart home application. And also for lighting services, we work with Philips and ASP. And for the storage, we work with some storage manufacturer like QNAP, Yodo. And then, IP camera, which is contribute a lot to our current business. Yeah, so basically we work with a lot of IP cam manufacturers, especially in Shenzhen, which really is a very big, important manufacturer, especially for IP camera. So this is a high-level overview for our platform here. So so for the device side, we have this SDK, so we can do firmware integration to the device. So the device can be any kind of device, IP camera or storage box. So we do integrate not just to Linux, embedded Linux, but also to RTOS, real-time operating system. And then for the cloud services, we do provide a full suite of all kinds of intelligence capability, including the push notification service, cloud recording, and the storage, and especially the P2P relay service that can really establish direct connection between the device and the client side here. So for the client side, we do provide generic applications and portals that's running on iOS, Android, or Windows. So these three components that make up our platform here, that's three key components in our entire platform. And this is also a structured overview of our platform here. So for the device layer, we work with a lot of different SoC chip manufacturers or solution provider. So then here for the connectivity here, we do support all kinds of different connections. So including AllJoyn protocol here, AllJoyn framework, and also ZigBee, Z-Wave, etc. And then for the cloud service here, we do provide several different kinds of components here. So we have this, the most important and also our core technology here is the P2P, point-to-point service, relay service here, and also push notification service, and also some also for the vSaaS, which is a cloud recording for the video surveillances, and also some other device management and the billing system as well. So I'll pick a few more important components to explain in more detail later. And then for application here, we do provide two main categories here. One is for the consumer product lines here. So basically including smart home devices, storage, wearable devices. And also now we are also working with some enterprise here to provide enterprise solution that's including smart retail and industry for Industry 4.0, and also smart agriculture, which can fit into smart city. And we also work with a third-party IoT platform as well. So we are not trying to compete with all other IoT platforms. We try to work with them. So for other platform, we do have some API modules to work with other IoT platform as well. So this is a very the most important module for our entire platform. Actually, that's also how we start our business. We provide P2P connection service in the very beginning, especially for the IP camera here, because for the IP camera, mostly is the video streaming. So if you have the video streaming going through a relay server, that will really cost a lot for the bandwidth traffic. But with the P2P solution here, the client side can directly connect to the device. You can do streaming directly without going through a server, so that can really save a lot of bandwidth here. So this is how we started in this IoT business. To have this kind of service, we started to build this kind of platform even before the IoT concept started. With this platform, then we also provide this kind of UID mechanism. So for each device, we'll assign a unique ID. So that's especially important in the very beginning because IP is not really abundant. And a lot of devices, they don't really have the public IP. They are also behind some router. So with each device assign a unique ID, and with our framework, we can just get the location, exact location of the device, and then set up the connection directly to set up P2P connection. So this is a very important component with our platform. And then the next one is for the service programming interface here. So we call it SPI. So this one is actually to work with other third party. Oh, sorry, I clicked it too fast. So this is to work with our third-party cloud platform. So so right now we also work with some other cloud service like Ali Cloud in China and 360. So they do have this. Because for that, they also want to try to connect you to the device to do some kind of control here. But with our service, they don't really need to build in their solution to the device. They can just use the interface to communicate with our platform to access to the device directly, without really going to the device to set up another firmware integration. So that will be much more convenient for this kind of cloud platform. And next one is a logic engine. So for this logic engine, actually it's the implementation of a very common IFTTT concept these days. So actually we can execute the task between the device in the local network to set up the rules for the device to talk to each other. So for example, you can set up for the IP camera to talk to a smart plug. So if you detect some kind of motion detect, then you try to turn on the plug. So for this kind of rule, you can actually store this kind of rule in the server or in the app. If you store in the server, actually you can also try to configure to control different devices to set up cascading kind of rules so that you can really have if this then that kind of concept building here for the with the logical engine here. So that's the architecture behind our logical engine here. So it's also going through this service programming interface to send out the control to different devices. And then for your client side to do the configuration and then try to set up the rules how these kind of different devices to communicate with each other. These rules can be stored in the server logic engine server, or you can store it in the application here, or you can just simply modify it with a simple user interface to set up a rule to do a different kind of control or status update. And another one is the push notification service. So for this push notification service, we work with the major two notification service here. One is Google's GCN for Android system, and the other one is APNS for Apple iOS. But for our push notification service, besides these two, we also support, for example, we also support Baidu push notification service, which is very popular in mainland China, because in China they practically disable the GCN service. So it's impossible, almost impossible for people in China with Android smartphone to receive GCN messages. So we do support Baidu here. And we also have our proprietary push notification services here. So we can do different kind of notification service besides the regular text message notification. We can also provide image, video, or scheduling the push, and even do the push notification analysis on the server side here. And then this is another important feature with our system here, with our platform. We provide video surveillance as a service, which is VSaaS. So if you are familiar with Dropcam, which is very popular in the US, they recently acquired by Google Nest. So for this is for cloud recording. You you put your video streaming from IP can store it directly to the cloud service, and then for you to do the playback from the client side. Then for our services, since we do focus on the video streaming connection here, so we do provide this kind of similar service that can really store the video streaming on the cloud side here, and for people to check it from your client side. And what makes it different from the Dropcam is that for other videos, this kind of cloud recording services, even for the real-time viewing, streaming viewing, they still need to go through the relay server. So everything needs to go to the server first before you can watch it, even for real-time video streaming as well. So that the cost is the same, whether you are watching a real-time video or watching playback, everything you watch is pulling from the video, from the server. So the bandwidth is still, the cost of bandwidth is still very huge here. But for our service, for the real-time video streaming, real-time video monitoring, we can do the P2P connection directly. Because for people, even with this kind of video VSAT service, most people will still want to watch the real-time video streaming. And then for our service, we provided P2P direct video streaming for the user. So that will be very, the cost will drop significantly, especially for our customer to provide this kind of service. They can cut down their bandwidth cost to a very significant number here. So that's really standards out from other VSAT services as well. So for our solution, we do provide cross-platform connectivity here. So for one important the important component for the firmware integration, we do work with all kinds of operating systems, Windows, Linux, Mac, iOS, Android. And the most important part is that we also support real-time operating system, RTOS here. Because RTOS is now it's become very popular, especially for those IoT devices. Because this kind of device are really resource limited here for the CPU or for the memory. So it's impossible to run this kind of heavy operating system, even for embedded Linux. So most IoT devices like a lighting or power plug, they will just use RTOS here. And our solution can also integrate into RTOS here without problem here. So that's really make us different from other IoT solution provided here. So, just to follow up with this kind of RTOS support here, so we do integrate our solution to the SoC level here, and so far we already support over 100 SoC chips here. So for the SoC support here, the most important part is really not the porting, but it's more about the performance tuning. You want to make sure that your internet connection is stable and your network transmission is really efficient without using too much resource. And there's not much packet loss, this kind of issues. So that also makes it very important here, since we can really support and really tune up the performance for all these kind of SoC here. So I think I probably talked too much about our framework here. So I think you probably can have some kind of simple understanding, a concept of what our platform can offer here. So next I'm going to talk about what we are doing here with AllJoyn here, how we integrate AllJoyn with our framework. So here I'm going to just do a very simple demo here. So this demo is it's a simple concept. Actually, it's also a prototype right now. It's basically a doorbell solution that's in a smart home environment. So I think I'm going to show a clip here. Actually, yeah. So for this demo, the scenario is like this. So you have this kind of door phone, which is kind of popular right now in the US, also in Europe. That you just install a door phone on your front door, and then when someone at your door, press the doorbell, then right now, most of the solution, you can receive this kind of notification from your smartphone app. But here we use AllJoyn to integrate into a smart TV device. So imagine that you are in your living room watching the TV and someone press the door button, and then you can receive a notification on your smart TV. And then you can decide whether you want to pull the video streaming from the door phone, from the camera on the front door to see who's knocking your door. So this is a simple concept here, how we set up this kind of scenario here. So I think I'm going to show a simple video here. This video is actually recorded in MWC by AllSeen here. So let me see if I can just play it.
ThroughTek as a COO positions. Today I want to demo to you is our Kalay platforms. Here is the Kalay app Kalay camera that we are having and demonstrated in the market already. And you can see this is our Taipei office. And now it's in the night time. We can have a lot of camera supported and change the pages quite easy. Okay? And also I can connect to the camera to see what is the real situation and to make it the zoom size as well. So it is quite convenient for our company and branding company to link to cloud and also apps immediately. So our Kalay platform currently supports more than 100 chipsets and has been deployed to the market for over 5 million devices activated. And the connection time to our cloud service is more than 75 million times per month. So in the demo case I'm going to do, we work with AllJoyn and also LG TV and set-top box manufacturers to have a demo case on the TV part. So when someone rings your bell, the push notification will have a warning directly to the TV. And also it will show on the set-top box informations. And then once you press OK, you will see the IP camera linked to the current situations, and also you can see who is really come to your home. In this way, you don't need to worry you will miss any visitors.
So this is our demo in MWC early this year in Barcelona. So I can talk about a little overview of the architecture for this simple demonstration here. So for this system here, because we want to have a door phone, and actually for this door phone we want to embed with AllJoyn framework and also our Kalay framework here. But since this is a prototype demo here, so we use a Raspberry Pi and IP camera to set up as a door phone here. And for the Raspberry Pi here, we have a Kalay Box SDK and also AllJoyn core service here, and also Gateway Agent framework. So I can talk about Gateway Agent later, how we use Gateway Agent. But basically here with there's AllJoyn basic services here, and especially the notification service framework. So there's also this set-top box here and the LG TV. And for the LG TV here, since this LG TV, it only supports notification service framework, and we also don't have access to the system. We just got this from LG TV from the market because it supports notification service framework. So we don't have a control over it. So that's why we also use another set-top box. So for this set-top box, we can build our service into the firmware here. So we have the Kalay Multimedia SDK here and also the AllJoyn notification service work here. So the scenario is like this. So when the button is pressed, so imagine it's a door phone here, someone press your door button here. So we use the AllJoyn notification service to send out notification to both LG TV and set-top box here. Actually, if we can embed this service to the TV here, we probably don't need the set-top box here. But still, it's a kind of convenient here. If you don't really have a smart TV, you just have a regular TV, but then you can have this kind of service built in with the set-top box here. So then, okay, so LG TV here, since it already supports AllJoyn, so it just simply get a message and show up on the TV, just show up the message you send out from the door phone here. And then for the setup box here, besides showing the message here, we also use our Kalay SDK to further show up a message box here, a button for you to check if you want to see directly the video streaming. So who is outside your door right now. So then for this kind of video streaming is use our Kalay framework. So you will just pull the video streaming from the IP camera directly and then show the video streaming here. So for the video streaming part using our Kalay framework, but for the notification, for the motion detection to send out the notification service here is using Kalay SDK. And then furthermore here we do also provide this notification to your smartphone here. That's where the gateway agent framework is coming here. So here we gather the information from the IP camera, the motion detection, and also the button press event here. Then we build our own simple gateway agent connector plugin here with our own, so to connect to our Kalay Cloud service here to our push notification service. So you can send out a push notification to our Kalay Cloud here and then push to the smartphone here. So then for the smartphone here, we have this gateway controller framework and also for the Kalay multimedia SDK. So here, let's say if you want to see the video streaming directly, you will use Kalay SDK to pull the image directly, the video streaming directly. Or you will go through the AllJoyn gateway agent to get a notification here. So it's just a simple concept and the work implementation about the integration between the AllJoyn framework and also Kalay platform here. So next, I'm going to talk about not too much technical detail how we do here, but we want to just to show how minimal effort you can do with the AllJoyn feature here to really get it to work with your framework here. So first, we need to know exactly what kind of service, what kind of feature you want to use for the two different frameworks here. So first, for the AllJoyn, since AllJoyn provide on the local network, it provides discovery and advertisement about service. It can just discover the device on your AllJoyn network here, and also it can show you what kind of device and what the device is capable of here. So it's very convenient to use this basic function, basic service to do the discovery and advertisement for your device here. And then next, we use this notification framework, which is also one of the basic services AllJoyn provide to send out a notification to other device. And finally, we use this additional gateway agent to push the notification to the cloud so it can receive it by the smartphone here. And then for the Kalay here, we provide some other services here. So first, we provide video streaming, so we can do the P2P video streaming directly from the device to your client side. And then for our Kalay Cloud service, we provide this push notification server for your push notification service to push to your smartphone here. And we also provide this connectivity over the internet so that your smartphone can directly connect to the IP cam to pull the video streaming here. So next is what needs to be done here on the AllJoyn side. So first, of course, you need to build the AllJoyn core. So that including AllJoyn router and AllJoyn bus and all the service to advertise what kind of device it is. For example, it's an IP camera, it's a smart TV, or it's a storage device. And then besides the basic services, you need to build in its notification service. Since we use this notification to send a message to the client side. So there are two parts. So actually, we just use this from the sample program. So it's quite easy. And next, I'll show up what needs to be done here in the sample program. You don't really need to tweak any code. You need to do a lot of code modification. You just need to get a sample program and then fill in some special attribute, then to set up this whole service here. So basically, there's two roles. One is the producer to send out the messages. For example, the motion alert to show that, okay, someone's at your door. And then for the consumers program to receive this alert to see if you want to receive this kind of message and if you want to take some follow-up action. For example, for the setup box for the TV to receive the message, and setup box can further to pull the video streaming from the IP camera. And next is for the gateway. So you need to build a GatewayConnect plugin here so that you can connect to your service here. So I think in earlier session I talked about some how to build this connector plugin here. But actually here we don't really get into that much complicated detail about plugin. Since here for our TPN, our push notification server, we support RESTful API service. So here for the connect plugin here, we just modify the Twitter script that's included in the sample program here to just send our simple API, RESTful API request to our service to finish this kind of push notification request. So here just some kind of sample. It's a very simple code snippet here. I try not to show too much things here. But here, if you look at the AllJoyn sample program, you just need to get a sample program. You don't need to go through all this framework to go through some more detail. You just get this sample program, and here you just show you how to send the messages. So for here, we just use a simple argument here to send out the message here. And for our service, because for all our service, we require specific parameter UID, which means that this UID is building with the device, especially for the IPCAN. You need to know which IPCAN you want to put a video here, so you need to have the UID here. So that's why we also have another attribute here. So this key one actually is our UID, and that's just it. Especially for the producer program, just these two simple parameters only. Oops, click the wrong button. And then for the consumer, it's really for notification, to receive the notification. So for the device here, actually, there's really not much to change here. It's very simple. It's just that when you receive the notification here, what you want to do here. So here, I just have this sample. I just store the message into a file. That's it. So I only just changed this simple code here. So when I receive the message from the AllJoyn notification, I just write it to the file. So that my setup box here can pick up this file to decide what to do next. In this file, I will store the UID for my IPCAN device, and then the message I want to show up here. So after I got this file, so my setup box can just parse this file and then to take the next following actions. So it's also very simple here. Just add extra line here in the sample program. And then for the gateway connectors, it's even simpler here. If you look at the GatewayConnector Sample here, the only changes here. So here there's the current sample, they have this Twitter script here, but here I just changed the script to our ThroughTek ticket script. And inside this script, actually just one line. It's just one simple API request to send out a message to our push notification server. It's just a simple like tps.ThroughTek.com/message equal to something. That's it. So earlier we talked about some connector plugin. Maybe might be difficult to write a plugin if you have different service here. But here for our service, since it's only right now we are only implement push notification service. So it's very simple, just write this kind of connector plugin here to make this work. So all the work on the AllJoyn side, just these three. Okay, first of course you need to build the entire AllJoyn framework to build in all this basic AllJoyn core service. But for the actual code modification, only these three parts here. And next is what needs to be done on the Kalay side here. Here I probably cannot even go further into technical detail because it might involve some of our SDK changes here. But still, if you're interested in this part, we can discuss later, and I can even show you how to do this here. But first, for our Kalay module here, so every device, we need to embed it with the UID to identify the device and then set up the P2P connection service. And besides the P2P connection service, we have this audio video module that's especially for the multimedia data to send out a video streaming here. That's for the device side here. So that's especially for the IP camera. So actually a lot of IP camera that's manufactured, especially in the mainland China right now, is already building with our service. So if you look at the IP camera with a QR code, on the button. So pretty much a lot of camera already use our solution. So with this kind of solution, actually all this is already embedded with the device already. So we probably don't need to do any work for the device side. But for the client side here, so first you need to get this UID from the AllJoyn notification message here, and then pass this ID to the audio video client here for the client to pull the video streaming. So in this sample demo here, so actually this client is working on the set-top box. So for the set-top box, pull the video streaming from the IP camera. So you can see the who's at your front door, who's pressing the button here. So that's it working on here. And then the last one is the script, as I keep saying, how we use the gateway agent here. It's really just a rather simple one-line script here with a simple RESTful API request sent to our TPS server to send out exactly what kind of message and what's the ID, who's sending this message. So so of course the smartphone here also need to embed it with our SDK so it can receive this kind of notification service to see who's sending this kind of message here. So that's pretty much what we do here for the integration. It's really not much work here. It's really a minimal effort. So let's just show how easy to work with AllJoyn and with your to integrate with your platform here. So next, I'm going to briefly talk about what the problem, what the issue we have when doing this kind of integration here. Oh, I think I pressed the wrong button again. Oops. Okay, so for the AllJoyn side, so I think the problem we have, at least in the very beginning, is really not understanding exactly what AllJoyn framework is. That's also what we have right now when we are working with some of our partners. They don't know exactly what AllJoyn can do. They just know that it can work with other devices. It can provide interoperability, but not sure exactly what kind of operation, what kind of interoperability it can provide here. So you need to know exactly what you want to do here. So then, at least for our demo, we utilize this notification framework, which is very simple to use. And then people might have false expectation about the AllJoyn framework to begin with. Especially AllJoyn work with the local area network if you don't involve gateway agent here. So actually everything needs to be done in the local area network. So if you expect some internet connectivity, then it's probably not going to work, at least in the very beginning, unless you involve a gateway agent here. And then the next one is how do you interact with other AllJoyn devices? For example, like the LG TV we are working with, since we know it supports this notification. So it's very easy, we just push a message here. But still, if you want to do something further, for example, first we really want to integrate with LG TV for LG TV to show the video streaming directly. But then, since we don't have the access to the LG TV's operating system, so we really cannot do much. And the LG TV is also using WebOS, so it's not as open as an Android system. If it is an Android smart TV, then it will be much easier for us to do our work here because we can just build a simple Android APK and install the TV to set up. Then we can do it further to have some more control over the TV after we receive the notification, what to do next. And then the next one is how you can integrate, how you work with, interact AllJoyn device with third-party device here. So if the current components really provide all the necessary capabilities, since we know that AllJoyn, right now they are, besides the basic services, there are also several different working groups, like a lighting working group, smart home, and there's also for other specific device here. So you want to know if you want to integrate with this kind of device, you need to know if the control, all the behavior really supported right now. Otherwise, you might need to do some kind of customization to do some kind of service so it can share by the different partners. So for example, recently we just worked with another company which is also AllJoyn member there. They produce a power plug here, and they build all the AllJoyn core services with their power plug. So it's very convenient for us to connect to this kind of power plug. So actually, right now we are also showing our AllSeen demo in Computex in Taipei right now. But for this demo, we add another device, another smart plug device here. And since this device already implements AllJoyn framework here, so we can, so for example, when you press a button, we can further turn on the power plug to turn on some light or speaker. So it's very convenient if you can really follow the AllJoyn protocol and build all this basic service first. So next, there will be some technical challenges here, but I think it's pretty common. Sorry, too fast. So I think for all, based on our experience, the most difficulty is really to fit AllJoyn to the device here. So for example, first we want to set everything up in the setup box, but to build a setup box, it really doesn't provide enough resources here, like a CPU or enough memory here. So eventually, we try to set it up on a Raspberry Pi device because AllJoyn is already proven that's working. And there's also a complete tutorial about how to build AllJoyn on Raspberry Pi. So that's why we choose Raspberry Pi to start our prototyping here. And there might be some conflict between the framework here. For example, there's some potential conflict between the AllJoyn device, AllJoyn framework and our Kalay service here. So that's really the issue you might run into in the beginning here. And next, I want to talk about some future possibilities since there's not much time left here. So basically, we have this prototype set up, and with this kind of experiment, we know further what we can do with the AllJoyn framework here. So besides this simple smart home device, actually we can do a lot of things, even for the AllJoyn to do the smart car connectivity here, and further to to expand to enterprise level, for example, smart retail. Imagine you have a lot of devices in a convenience store, how you use AllJoyn to connect this device within this room here, and then use our Kalay framework to connect outside, to collect data, to do some further analysis. And even further for the smart city, smart building here, there's a lot you can do here since with the feature provided by AllSeen. And after you integrate it with your framework, how you can take advantage from both sides and then make your product more realistic and more useful. Okay, so that's some of my presentation here. So I think I probably used too much time here. There's not much time left for Q&A, but I think I can still take a couple of questions. But if there's not enough time, so feel free to come forward. I'm very happy to explain further because I probably did not cover enough details in this presentation, but definitely welcome any questions you might have. I'm very happy to discuss further with you about our experiences and what we do here with our Kalay framework as well. Okay, thank you.
Is there any C library? No, C++, just C.
You mean for AllJoyn or for all? Yeah. Actually, all the framework is written in C. You just compile it. So you can just, if you want to build it up in some other device, like so for example, we also build it on the setup box, and this setup box is a MIPS device. So we just use that tool chain with AllJoyn framework to build the core services. So yeah, it's a C, C++. So I think pretty much you can really build it into different devices. Yeah, as long as you have the right tool chain to do that. Okay. Yes.
Demonstration. Why your Bluetooth device was installed on the Raspberry?
Yeah, so because it's really for the prototyping here, and it's also we want to Actually, for the door phone, actually right now there's already this kind of product here. You have this door phone with a button and with a video camera here. But currently, this product is it's not really. It's a very small device, and we want to build an AllJoyn and our framework inside. And because of the MWC demo, there's really not enough time for us because you need to really compare everything to use ThroughTek to build all the services here. So that's why we choose Raspberry Pi first. Because Raspberry Pi has much more resources, it will be much easier for you to put everything inside, all the basic AllJoyn, basic services, and other additional services. So that's why we use that to set it up. But actually, right now, we already built a prototype with this kind of device already with AllJoyn and our Kalay framework to a simple device. And it's an ARM-based device. So actually, right now it's still a prototype, but actually it's doable. Because for AllJoyn, actually there are some services you probably don't need that. Yeah, you probably just, besides those very basic like about service and the discovery advertisement, so at least for our implementation here, we just need another notification service, and that's it. So for all other services, we don't need that. So you can just get rid of the other services you don't need and try to make your code size as small as possible to fit into the firmware, the device you have. But it's just auto convenient, and also because of tight schedule, so we set it up on the Raspberry Pi. Yeah.
Previous presentation, I heard that AllJoyn will automatically find the supporting protocols to use it. So in your platform demonstration, does Raspberry Pi have Bluetooth and Wi-Fi and all that?
No, it's simply just use just wired connection. It doesn't use Bluetooth or ZPZ at all. Yeah, because we just use this because AllJoyn is still running on top of the network layer. So you don't really need Bluetooth or ZPZ way. If you use ZPZ, of course, you probably need another gateway service to build out the connection and then connect to that gateway first. But here with Raspberry Pi, actually you just have everything here on the Raspberry Pi because it's already provided wired connection here. So that's why I say if you want to do some experiment, do some testing, then it's very simple. It's very easy to start with the Raspberry Pi. Okay. Okay, so feel free to ask me questions. So I think it's already about time here. Okay, thank you.